So in this video, our goal is to determine the sum of the measures of the angles, of the interior angles of any polygon, whether it's the triangle that we did last chapter or up to many, many sided polygons. That's what we want to do. We want to find the sum of the measure of the interior angles. And you know triangles, and you probably also know quadrilaterals as well. What do you think the sum of the measures of the four interior angles of any quadrilateral is? Can you fill in the blank? Sure, you probably remember from previous courses that it's 360 degrees. Exactly. And maybe what you recognized was that if you have a quadrilateral, that what you could do is you could draw in a diagonal. And your diagonal created two triangles, each of whose sum of its angles is 180 degrees. So 2 times 180 is 360. So the sum of the measures of the interior angles of a quadrilateral is 360. But let's extend that a little bit. Suppose you want the sum of the measures of the angles of a pentagon. Remember, a pentagon has 5 sides. And again, divide into some shapes whose angle sum you know. Here's the pentagon. So maybe what I'll do is I'll draw in some diagonals to it. I'll draw that one in there. And I probably do not want to draw a diagonal that crosses that one, because that's going to make a lot of other shapes in there whose vertices, like other triangles or other figures, whose vertices are not the 5 vertices of the pentagon. So maybe I'll go from this same vertex and go up here. So now I have 3 triangles, each of whom's angle sum is 180. 3 times 180 is 540 degrees. Very nice. So I think we get a little bit of an idea here. Suppose we wanted to sum the measures of the interior angles of a hexagon. Well, you're probably saying, well, what if I just add another 180 onto it? Or an octagon, well, I'll add a couple of 180s onto it. We want to generalize it. We want to call it, say, an n-gon. So the idea here then is, what's the relationship between the number of sides a polygon has and the number of triangles that can be formed by drawing diagonals from one vertex? So do you like clams? Why do you say that? Well, this is my clamshell diagram that helps you remember how to find the measures of the angles of the interior angles of a polygon. So if I start at this vertex down here, what I recognize is that since I can't draw a diagonal to that vertex, and I can't draw a diagonal to that vertex, because those are its sides, I can draw to 2 fewer vertices than the number of vertices of the figure. So perhaps we know that if the polygon has n sides, then you can create n minus 2 triangles. And think about it before. We said in a quadrilateral, 4 sides, we drew 2 triangles. In a pentagon, 5 sides, 3 triangles. So it seems like that pattern holds true. So then, can we complete our conjecture? The sum of the measures of the n interior angles of an n-gon, an n-sided polygon, is, what do you think goes in the blank? Knowing that if it has n sides, it has n minus 2 number of triangles, and each triangle contains 180 degrees. So that will give us an expression that we can determine the sum of the measures of the interior angles of a polygon.